The other day there we did sample 1 here, the Demon Drop. I think I've rearranged the order of these for future generations. So the next one we did was the tennis ball one. Am I correct? Which I think might be example 4 in your booklet. Is that right?
Yes.
Okay, so I've just made some changes for future generations, that's all. So we'll skip past those ones. And let's go to the number, well, it says example 2 now. I guess that should be the current number 3. Canada's Wonderland. Anybody been there before? Yeah? It's a great place, eh? Oh, you don't remember? Yeah, we thought we were going to spend a day on the rides and a day on the water slides, and we never actually got to the water slides because we had so much fun on the other. Yeah, I know. And they have one of these drop rides, and I literally did stand there and go, I wonder how tall that is. And then I figured it out. You really need to rest your voice, Hannah, for tonight, I think. Oh, is that right? Okay. Oh, I was concerned. Okay, so Canada's Wonderland has a drop ride that is 230 feet tall. That's true because I looked it up. How fast are you going when you reach the bottom of the ride, not the rider? Does yours say rider? And how long does it take to reach the bottom, assuming that we are going to free fall? Now, the last few feet, obviously, they're going to slow you down because they don't want you to crash and burn at the bottom. That's probably bad for business. Because we know gravity in meters per second, we're going to have to do what? We're going to have to convert. Does anyone know how to convert feet to meters? Something like that, but you've all got, many of you have smartphones, so why don't you just type in 230 feet in meters? Would you do that for me? Ryan's going to do it for us. Riley's going to back him up. And you're going to text him. $230 feet. It's around 3 feet per meter. So divide by 3-ish.
70.104 meters.
We'll say 70.1 meters. Thank you, Ryan. All right, so we'll work with that. Now, the question is, we do know the initial velocity is 0. The question is really, how fast are you going at the bottom? So what is the final velocity? And how long does it take? That's our t. Anything else that I know in this problem? Oh, I know the distance. I guess this is my d, right? Anything else? Yeah. I don't want to. Yes, Hannah's correct. The gravity, the acceleration is minus 9.8. Does the minus matter? Is the displacement all in one direction? Yes, it's just down. In fact, this 70.1 should actually be negative. But because everything's in one direction, we can, if you really, really want to, we could say, you know what, for this particular question, let's just make down be positive. Is that okay to do that? It's okay, right? No one's going to get hurt. It's not like just saying, you know what, today I feel like red light means go. Okay, a little different, right? But in this particular situation, we can define that. So, no, in this case, I wouldn't worry about it. That's my point, is you have to recognize when it is important and when it isn't. It's not important this time because all the direction is down. Okay, so we are looking for the final velocity. Now, one formula with final velocity in it, don't write anything down because I'm going to do some thinking here. A equals delta V over delta T, right? I could get to VF from delta V, right? Because I know the VI, but do I know the time? I don't. So, like, what am I going to do here? Well, we've also got V bar equals D over T. I know the D, but I don't know the T, and I don't know the average. This is one of those ones that you're going to have to set up a system of equations. These are the ones that I love, students particularly hate. So, based on, you can start writing stuff down now. Based on, V bar equals D over D. What can we, I know the D, but I don't know the T. And we're going to have to come up with T. Could I say, I'm going to write V bar equals VI plus VF over 2. Now, the initial velocity is equal to what? The initial velocity is equal to 0, so that in fact actually disappears. Would you agree then that V bar is the same as VF over 2? Everybody good with that statement? Okay, so I'm going to write over here for V bar, I'm going to write VF over 2, and I'm going to write it in blue, equals D over T. And what I've done now, well, actually, could I replace? I'll do it one more step. I'm going to write VF over 2 is equal to 70.1 over T. And I've now got one equation that has two variables in it, VF and T, both things that I need to find. Can I come up with another equation that has those as well in them? Well, we also know, just see if I can I do that? Yes, I can. Excellent. I'm going to write over here, A equals delta V over delta T. And we know that delta V is equal to VF minus VI. And once again, the initial velocity is equal to 0, so that one disappears. And are you comfortable with saying that delta V is equal to VF in this case? Yeah? So now I can replace this delta V here with a VF over, do I need the delta that goes with the T? It's kind of, we've sort of been a little bit loosey-goosey with it. It really just means change in time. You only really have to worry about the delta part when there's like starting at T is equal to 3 and it's going to T is equal to 8, and you got to make sure you subtract them. But for the vast majority of the time, the initial time is 0 and the final time is just T, and it's just the delta T is T, right? It's just T because the initial is always 0. So that's why we can get rid of that. Now, do I know my acceleration? Sure do. It's 9.8. So 9.8 is equal to VF over T. And you'll notice that I now have two equations here, right, that each have two variables, and those variables are the same. They are both VF and T. What do you do when you have a system of equations? Now, you might remember from math, and I'll just sort of go on the side over here. I'll just insert a little page here. You might remember x plus y is equal to 10, x minus y is equal to 6. Remember seeing those kind of things? And how there was two ways to solve them. Anybody remember what they were? Anderson, you may not have seen these yet. Well, neither of the techniques is considered dumb or stupid. The techniques are add them together, and when you do that, you get x plus x is 2x, and y plus y and a minus y cancel to nothing, and you get 2x equals 16, and then you get x equals 8, and you plug that x into there, and you solve for y. That's called the addition and subtraction method that you may be familiar with. Okay? But math, have you seen that in math, Dana? Yeah? You hated it? Oh. Well, there's also the other one, which is called the substitution method. Maybe we'll get better because you're going to have to do it now. There's also the substitution method, which means you can take one of these. I could take this here and rewrite that as y equals 10 minus x. And then I take this 10 minus x, and because it's equal to y, is it equal to that y? Uh-huh. And so then you would write x minus, oh, I picked the wrong one, y, which is 10 minus x, is equal to 6. And then do the subtraction. So I got x minus 10, and a minus x is really plus x. So I've got x plus x is 2x minus 10 is equal to 6. And then you just solve that, right? Remember doing that kind of stuff, Dana? Okay, so that's what we're going to have to do. Except it's not going to be nice and neat with just nice x's and y's. It's going to be ugly with VF over 2 is equal to 70.1 over T, and 9.8 equals VF over T. Sort of the ugly stepsister of the system of equations family. My apologies to all the stepsisters out there. Okay, so which one of the two would you like to try? Would you like to add those together, or would you like to substitute? Which one feels like it would be easier? Any guesses? No, cross multiply doesn't work. When you add them, you have to have like a plus y and a minus y. So when you add them together, they cancel. Well, who wants to add these fraction things together? No, not me, not at all. Could I do it? Yeah, I could, but yeah, I don't want to do it. Substitution is far easier, and to me, it makes a lot more sense. Let's solve. Which one of these variables do you think is easiest to solve for, or to isolate? Have you heard that? Isolate? Okay. Which one, Jason? This time here or this time here? This time over here? Really? Why do you think I go, really? Well, is it possible? Yes, it is. It's not the easiest one, though. Was it you, Ryan, or was it Zach? Because there's a variable on top. And who wants, like, you're going to have 1 over t, and you don't want to deal with that, right? Would it be easy to get rid of the t and just have VF all by itself over here on the top? Yeah, relatively easy. How would we do that? We would do that by multiplying both sides by t, and then multiplying this side by t. And you would end up with VF is equal to 9.8t. Okay, I think for the most part, you guys should be able to see that. I'll pause there for a second, let you soak it in. Now, does this red VF equal that blue VF? The color doesn't matter, they're just VFs, right? So that means that if 9.8t is equal to this VF, then 9.8t is equal to that VF. So let's do that. Let's write that VF with 9.8t over 2 is equal to 70.1 over t. And what have I now just done? What did I create? Well, a fraction monster, I suppose, right? But it's an equation that's only got how many letters in it? It's only got, well, it's got 2, but they're the same. Can you solve equations with just 1 in them? Absolutely. Now here's where the cross multiplying comes into, Jake. So let's cross multiply. So 9.8t times t is going to give me 9.8t squared. Right? 9.8t times t is going to give me 9.8t squared. And 2 times 70.1 is going to give me 140.2. Can you solve this little equation? Yeah, you should be able to, I think. In grade 11, based on your mathematical experiences, you should be able to go t squared is now equal to 140.2 all over 9.8. And now I got to flip to my sheet because I can't do all that in my head. Did I do it the right way? Yeah, I did. Oh, and then you got to take the square root of it, right? I don't know what that would be. T is equal to the square root of whatever that is, and it's equal to 3.8 seconds. Does that seem about right? For something to fall 70 meters, how tall is 70 meters? Like, what around this area is about 70 meters tall? Yeah, maybe something like that. Over here. Would the gym be more or less than 70 meters? Considerably less, right? Like the gym's probably only about maybe 20 meters. So yeah, maybe one of the elevators. The seniors high rise would be probably taller than 70 meters. Maybe not. 100 meters is quite a long ways, right? Length of the football field or so. Okay, so 3.8 seconds. All that is how long does it take? How do I figure out how fast you're going? Because that does ask for that too. How fast are you going? Well, can I just use this VF equals 9.8t? Yes, I can. I'll take that 3.8 and I'll plug it in there, and I'm going to go VF is equal to 9.8 times my time of 3.8 seconds, and I'll spare you the math. Minus 37. Well, it would be minus if you put the negative in there with the 9.8. So 37.1 meters per second. These are all just really kinematics questions vertically. That's all they are, right? More of the same. Suppose that a ball is dropped from a tower 70 meters tall. Oh, that's almost exactly the same as the last one, isn't it? How far will it have fallen after 1 second? As soon as you see how far, right away, alarm bell should go off in your head. Oh, how far? Average velocity. I got to have average. What's the initial velocity? 0, right? My time, 1 second. My acceleration, 9.8. I'll go through this one quick. A equals delta V over delta T. Do I need the minus with my 9.8? No, it's all one direction. 9.8 equals delta V over 1. Change in velocity is 9.8. Therefore, the final velocity is 9.8. That's only true when what is equal to 0? Then the initial, right? It's only true when the initial is equal to 0. And so if the final is 9.8, then that means that my average is going to be VI plus VF all over 2, 0 plus 9.8 over 2, or 4.9. Meaning now V bar is equal to D over T. 4.9 D over 1 second. How far does it go, or how far has it fallen after 1 second? 4.9 meters. I'll pause there for a second and let you jot that down. All right. Okay, so my question to you is, the next part is part B. It's how far will it have fallen after 2 seconds? Could you just take, if it falls 4.9 meters in 1 second, well, isn't it just going to be like 4.9 times 2? Isn't it just going to be like 9.8 after 2 seconds? No, Joey? So, does that matter? Absolutely, good for you. You can't just do that. Do you want to take a guess at how far it's going to have fallen after 2? Yeah, it's traveling faster, right? Absolutely. It's going, after 1 second, it's going 9.8, right? How fast is it going after 2 seconds? Like, what's different here? What's the final velocity going to be after 2 seconds? (9.8 times 2, 19.6. What's the average velocity going to be? 19.6 divided by 2, which is? Well, I thought we said it wasn't 9.8 meters. What's the VI? It's falling 2 seconds. The initial velocity is still 0. Yeah? But you're on the right track. The average velocity is 9.8 meters per second, but now the time is 2, exactly. So it's going an average of 9.8 for 2, so actually the displacement is 19.6. I'm going to change this example question. I'm going to change that fourth. I'm going to change that to during the second second. How far does it fall during the second second? In other words, from 1 to 2. Well, where is it at 0? At the top, it's at 0. Where is it after 1 second? 4.9. Where is it after 2 seconds? Which means that during the second second, it falls a total of 19.6 minus 4.9. I don't have it actually. I'm going to have to figure that out. That's going to be 6 minus 9 is going to be 7. 14.7? Yeah? My concussion doctor will be happy. I can subtract in my head. Let's see if Mr. Thacker. How far does it travel during the first second? 4.9 meters. How far does it travel during the second second? 14.7. Why does it travel farther, Abby, in the second second? Because it's going faster, right? Yeah. Okay, let's change gears a little bit. Let's look at an elevator kind of question, a weight question. Okay? These are sort of the second kind of questions that appear in this unit. So a man standing in an elevator has a mass of 60 kilograms. What is his weight if the elevator is stopped? Well, that's the easy one. It's not 60 kgs. What is his weight? Weight is measured in newtons. FW equals mg, so it's going to be 60 times 9.8. I think it's 596. No, 588. He weighs 588 newtons. If there was a Newton scale like mine on the elevator, it would register 588 newtons. That's kind of the introductory question. It's supposed to be easy. Okay, what if he's accelerating upwards from the ground floor at 1.5 meters per second squared? Is he going to weigh more or is he going to weigh less than 588 newtons? When he's accelerating up at the bottom, more. How much more? Acceleration times mass more. Great answer. Exactly. Now, how do you write that, right? Like I've been yelling at you to write the formula. Okay, I want to write the formula. How am I going to write that? This is the way I like to show it. I'm going to write FAP, his apparent weight. FAP, his apparent weight force, is equal to his weight force plus, as Jason eloquently put it, his mass times his acceleration, right? And there's an additional force needed to accelerate him. If it's just holding him in place, it's just 508 newtons. But he's also got to be accelerated at 1.5. And so it's going to equal 588 plus 60 times the acceleration of 1.5, which is 678. Does he weigh more? Yes. Is he supposed to? Yes. Now here's where you got to be careful with your negative signs. And you also have to remember that the weight that is shown is not really a vector, it's just a number too. So you have to be very careful here. I have to be careful, you have to be careful. Your best bet is to just think, does he need to weigh more? Does this number need to be more than this one? If so, I have to add. Okay, and I always get people that struggle a little bit here. Now, what if he's slowing down at 2 meters per second squared as it approaches the top floor? It gets to the top. How do you feel when you get to the top of a fast-moving elevator? You feel lighter. So the number is going to have to be less than that. How much lighter? I'm going to ask Jason again because he said it nicely the first time. How much lighter is he going to weigh as he approaches the top floor, slowing down at 2.0 meters per second squared? You said it perfectly the first time. Mass times acceleration less. Exactly. Exactly. So we're going to write FAP is equal to FW plus MA. But this time, because it's slowing down and he's going to weigh less, it's going to be a subtraction kind of thing. So we're going to write 588 minus 60 times 2. And you're going to subtract. And you're going to get 468. Does he weigh less? Yes. Is he supposed to? Yes. All right. I'm going to pause there. There's 2 more parts here. I've given you the skills to be able to do these. You just have to figure out which one of the 2 things do I do. Do I add or subtract for this one, or do I add or subtract for this one, or is it the same for both? So I'm going to give you about 5 minutes to sort of discuss that with a partner, and then come up with 2 answers for these next 2 here while I do my attendance. All right, so the second last one there, when you're accelerating away from the top floor at 1.8, are you weighing more or weighing less? You should weigh less, exactly. So you should have got, for this one here, you should have got 480. Did you get that? And then the bottom one, Hannah, do you weigh more or less? Or say, did I say less or less? More or less? It's more, yeah. So even though when you accelerate upward at the bottom, or you slow down at the bottom, you still weigh more. Where do you weigh more in an elevator? At the bottom. Doesn't matter whether you're going up or coming down, you weigh more. At the top, you're either slowing down and weighing less, or you're pulling away and weighing less. At the bottom, you weigh more. At the top, you weigh less. All right, I'm going to stop there for the day. You have two sort of sets of problems. You have that problem pack set. You have these extra ones here. I urge you to do as many as possible, especially the Kyle and the helicopter ones. I'll go through those for sure on Monday. We will do the lab as well, okay? And then move into friction stuff starting next week. We got 2 weeks left, right? Yeah, so we're definitely going to have that test before break, so that is all.